Okay, welcome to ER7's planet. In this planet, it rains mathematical scopes while it rains H2O on planet Earth. In this video, I'll be explaining what congruent triangles are. This is a prerequisite to a video which I promised um, on my WhatsApp status that I'll be dropping a video on circle theorems. So before we dive into circle theorems, one of the things we have to understand is congruent triangles, because we need that in one of those proofs. So this is like to wet the floor before we go into that. So quickly, what are congruent triangles? Two or more triangles are congruent. It means they are equal. Yes, in simple terms, it means the two triangles are equal. Okay, so if I have two or more triangles and I want to check or establish or say that they are equal, I can't just say that out of my sentiments or by mere just saying. No, we need to establish some facts. Actually, some conditions have to be met before two or more triangles can be said to be congruent or equal in quotes. So these conditions will be checking the three sides and the three angles of the triangles involved. Although it's not, we don't have to check all the six. I mean the three sides and the three angles. We don't have to check that. We just need to check for one of these five conditions. Okay, let me zoom this a bit. So one of these five conditions which you can see, we can see the first condition, SSS. That's a short form of side, side, side. I'll explain what that means. We have the second condition, SAS, which is side, angle, side. We have the third condition, ASA, which is angle, side, angle. And we have AAS, which is angle, angle, side. So those acronyms, that's what they stand for. Then we have the RHS, which is R for right angle, H for the hypotenuse, and S for side congruency. So these five conditions will be checked. So now, what are these five conditions in plain sentence? Now, let's look at the diagram for the first one. Here I can see two triangles, triangle ABC and triangle QPR. So ABC, we can see it here, and then we can see triangle QPR. We can see that one here. Now, if I look at these two triangles, I will see that the side AB stroked once, side BC stroked twice, two times, side AC stroked three times. That's telling me that all those three sides are not equal. That's like a scaling triangle. That's why they are stroked different amount of times. But if I look at the triangle QPR, I'll see that QP also got stroked once, just like AB here. So what's that telling us? That's telling us that the side AB from this triangle is equal to side QP in the second triangle. So side AB in the first triangle is equal to side QP in the second triangle. Okay, then looking at it here as well, the side BC is was stroked twice here. Then side QR also 2 times. So that's telling us that they are also equal. Then the side AC and the side RP. So it means that 3 sides there are equal. Yes, 3 sides are equal. Okay, so we say that 3 corresponding sides are equal, or 3 sides from one triangle is equal to the 3 sides from the other triangle. So once you can see this condition in 2 or more triangles, then we have established the what, or we have seen the condition of SSS congruency, which means 3 sides from one triangle is equal to 3 sides from the other triangle, or just simply say that 3 corresponding sides are equal, or just simply say 3 corresponding sides are equal. So that's the first condition. Now, how do we name the triangle? We have to be careful here when naming the triangle. That's when we want to write the congruency. Okay, for example, if I say triangle ABC, triangle ABC, I will say that this triangle ABC is congruent to triangle. I have to be careful on how I name this as well. Will I say PQR or QPR or RQP or RPQ? Yes, we have to be careful here. Now, if I look at the ABC, I will see that I started with A, then I moved through what? The shortest of the 3 sides towards B, then towards to C. That's following that direction from the side that was stroked once to the side that was stroked twice, then move to the what? Back to A. So I'll follow that same direction. If I want to name the second triangle, I will follow the same direction. Okay, meaning I have to go like this. Since I've named this one ABC, it's compulsory I move like this from angle P. I have to move in this direction. That's PQ. Okay, similar to AB, then QR. Just as I moved here, A to B, that's the side that was stroked once, then I moved through the side that was stroked 2 times. So the same thing here. So I'm moving from P to Q, then from Q to R, then from R back to P. So that means I'll name this triangle PQR, not triangle QPR. Yes, so if I say ABC is congruent to QPR, that's actually wrong. That's not correct. So we have to also watch the way we name the triangles when stating the congruency. Okay, so that's for the first condition. Now let's move to the second condition, which is SAS congruency. Now this SAS congruency is when I have 2 corresponding sides and an included angle. 2 corresponding sides and an included angle. Now if I say included angle, I mean the angle between the 2 corresponding sides. Let's look at the diagram to explain that. if I look at the triangle, the first triangle here, okay, two sides were actually identified with the number of strokes. That's the side AB and the side BC. Okay, side AB stroked once, side BC stroked twice. Now, there is an angle denoted between the two sides, this angle here. So we can see that the angle B, that's the angle ABC, is found between the side A, the side AB, and the side BC. Okay, so this one side, this another side, then the angle is in between them. So you can see that SAS. You can see that SAS. So this angle is called included angle because it's found in between the two sides. So this angle is the included angle I was referring to here. This A we are having here. Okay, that's I can even say that it's in between what? S and S. So that's SAS. So now, how do we check this particular condition when we have two triangles? Okay, so let's look at these two triangles as well. Now I'll see that the first triangle, the side AB is equal to side PQ. I can see that they are both stroked once, so that means they are equal geometrically. Then the side BC is equal to side QR. Okay, you can see I'm being careful now with the naming of the side as well. Yes, I didn't say RQ, I said QR. Okay, so we have to be conversant with this, and it even helps in vectors as well. Once we get to algebra of vectors, it helps when we can name triangles in order. So BC is equal to QR. Then the angle between them also what's been denoted as what? They are equal. So if I see that for two triangles, two corresponding sides are equal and the angle between them is also equal. Let's say, for example, here happens to be 40 degrees. Just for example, let's say the angle here is 40 degrees, then this one is also 40 degrees. And let's say, just for example, trivially, let's say this place is 3 units and here is a 6 units. So here should also be 3 units and here should also be 6 units. So with this, I can establish that, okay, these two triangles are congruent because I have two corresponding sides and an included angle to be all equal. So that is what the SAS congruency stands for. And I hope that's clear. So to name this, I will say triangle ABC is congruent to triangle PQR. Yes, ABC is congruent to PQR. Okay, I can't say ABC is congruent to QPR. No, I have to follow the order. ABC, A through the side 3 to B, then from B to what? To C through the side 6 units. So the same thing here, P through the side 3 units to Q, that's PQ, then from Q through the side 6 units to R, so that's QR, so PQR. Okay, so I hope that is clear. Please do like, subscribe, share, and leave comment in the video so that we can get feedbacks. Maybe there's mistake, addition, subtraction, whatever you want to add, and give us thumbs up and kudos. Give us comments if you gain anything from this video at all. Okay, now let's continue. The third the third condition, ASA, that's two corresponding angles and an included side. Two corresponding angles and an included side. So that's what this third one stands for. ASA, two corresponding angles and an included side. So which means there are two angles that are corresponding, and then there is the side in between the two angles. So let's look at that here from the diagram here. So we can see that we can see this here. This angle angle A and angle P. We can see that they use color green to identify those two angles. So which means they are equal. So these two angles are equal. Then this angle B and angle Q, they are also equal. Looking at the way they have been painted, so they are also equal. So that means two corresponding angles are equal. Then there is a side in between the two angles. So we'll see that there is a side AB. There's a side AB that connects the two angles. So this side is the included side. Okay, this is one angle, this is another angle, and this is a side. Okay, so this is the included side. So we'll see that this side in the first triangle stroked once. Then similarly in the other triangle as well, the side between those two angles also what stroked once. So which means they are equal. Okay, that is AB is equals to PQ. So with this, I can see the condition of what? ASA. A, then S. And the same thing here. A, then S. So that is what the ASA condition. So once I see this, I don't need to check any other thing for the two triangles. I can say that the two triangles are equal. Okay, and mind you, once you say that two triangles are equal, it means they will share every other thing to be equal. Okay, so which means this third angle here will also be equal already. That's what being equal means. So if these two are already equal, so the third angle will be equal. Yes. So here I can say that the triangle ABC is equal to triangle PQR. Yes, PQR. I have to follow the order. Always important. That's why I'm reiterating that in each of the conditions. You have to follow the order. Okay, let's move. The fourth one, that's AAS. That's I have two corresponding angles. So the AA there means two corresponding angles. Then one non-included side. Yeah, this S here is not in between the angle. It's not in between the angles rather. Okay, unlike the third one, which is in between the angles. So this S here is non-included side. That is, I have two angles, two corresponding angles, and non-included side to be equal. Let's see that with the diagram. Okay, if we look at the diagram, we can see from the first triangle, the angle A is equal to angle P. Okay, looking at the color being used. Then angle C is equal to angle R. Okay, so those are the two angles, that's the two corresponding angles that are equal. Okay, but the side that is being denoted here, the side AB. So we see that the side AB is not in between the two angles. It's not there. Okay, the same thing in that triangle. The side PQ is not in between the two angles. Okay, so definitely this is AAS. AAS. Yes, AAS in that direction. So this AAS in that direction. So this is the condition for two corresponding angles and a non-included side. Okay, so if I will name these congruency now, these two triangles as congruent triangle, I can say that so let's say I want to move in this direction. Okay, let's say I want to move in this direction from this side down to this side. So I can say triangle CAB. Triangle CAB. That is, I move from this angle C to angle A, then to the non-included side. So I can say triangle CAB is congruent to triangle. Then I'll do the same thing, the same direction here. Okay, I'll move from the angle R. So that's triangle RPQ. Yes, triangle RPQ. Okay, so I'll move in that same direction, showing that angle C is equal to angle R, angle A is equal to angle P, and side AB equals to what? Side PQ. So that's triangle RPQ. So that's how to state it, triangle RPQ. Although we can also state in other ways. Another way I can state it is that I can also say that still the same triangles. I can name them another way. Yes, so far I follow the order. Okay, let me try to explain that now. Okay, let's say I name this triangle ABC. Yes, let me use that. So let's say I want to name this triangle as triangle ABC. Now I have to study my direction here. Okay, if you look at it, I moved from the angle A. I moved through the non-included side. Okay, I moved from angle A, moved through the non-included side to another angle B, then to the side facing angle A towards angle C. Okay, let me use an arrowhead now to indicate my direction. So I'm moving like this first. Sorry about that. I move like this first, then move like this. So that's ABC. So now I have to follow that direction in the other triangle. So triangle ABC is congruent to triangle. So how will I name the second one now? So I moved from angle A in the first one. So I have to move from which angle is equal to angle A in this second triangle. That's angle P. So I'm moving from here. So that's my starting point. Okay, so I'll move from the same angle that is equal to angle A. So that is angle P. So that means from P, I'm moving through the non-included side. Oh, sorry, I've mixed that up. Actually, it's here. This is it here. It's this place. So A, then move through non-included, then move through here. So I'm moving from this side here, angle P. So angle P, move through the non-included side, which is to Q, that's PQ. Then from Q, I move towards to R. So that means the triangle is congruent to triangle PQR. Yes. So I can also say triangle ABC is congruent to PQR. Okay. Or I will say triangle CAB is congruent to RPQ. Okay. I can't say triangle CAB is congruent to PQR. That's a wrong statement. Yes. So the order matters a lot when naming congruent triangles. Very important. Okay. So that's the fourth one. Then the fifth one, this one is specifically for right angle triangles. That's if I have two or more right angle triangles. So let's say I have two right angle triangles. How will I know if the two triangles are congruent? Okay, so the congruency condition to look out for is RHS congruency, which R stands for right angle, H for hypotenuse, and S for corresponding side, meaning both triangles must have right angle. Of course, from the name, right angle triangle means they have 90 degrees, that's right angle. Then their hypotenuse must be equal. The hypotenuse of one triangle must be equal to the hypotenuse of the other triangle. That's the H in that acronym. And the S means they must also have what? A corresponding side. So meaning one side from one of the triangle is equal to one side from the what? Other triangle. Let's see that in the diagram. Let's see that here. So if you look at this triangle A, the two triangles, yes, I don't want to name them yet, the two triangles. So we'll see that they both have 90 degrees. You can see the symbol for 90 degrees. Once you see an angle and this square corner is denoted, there's 90 degrees. So there's 90 degrees here, there's also 90 degrees here. So that's R. So they both have 90 degrees. Then the hypotenuse, that's the AC and the PR. So we see that they are both stroked once. So to tell us that they are equal, that's why assuming this one was stroked once and this one was stroked twice, so that means they are not equal. Yes, let's say this second triangle was stroked twice like this. So that means AC is not equal to PR. So definitely the two triangles are no more congruent because there's no way the H can be what? Established to be equal. So, but in this case, both stroked just once, so which means they are equal. So we have H to be equal as well. So that's RH. Then the side BC here stroked twice, and the side QR here also stroked twice. So to show that they are equal, that's BC is equal to QR. So that means both triangles have corresponding side to be equal, and that is RHS. That is the right angle, hypotenuse, and corresponding side are all equal. So once I can see this in two right angle triangles, I can see that they are congruent triangles. So how will I name this? I can name it in many ways. Let me try to name this one without using the customary ABC. Okay, let me use BCA. So let's say I'm calling this first triangle here, I'm naming it triangle BCA. That is, I'm starting from the right angle triangle, that's B, which is this B here. Then I move to angle C. Yes, move to angle C through this side that was stroked twice. Okay, that's BC. Then I move from there to angle A. That's through the hypotenuse. I pass through the hypotenuse to angle A. So I usually visualize like I'm moving on the road. So that's what I'm saying, I'm passing through like a road, trying to make it real instead of being abstract. Bring abstract to reality as much as possible. That's one of the important things in mathematics. No matter how abstract it is, try to make it real with your imagination. So triangle BCA is congruent to triangle. So how will I name this? I can't call it PQR. That would be wrong. or QPR, that will be wrong. So definitely, since I started with the right angle here, I'm also going to start with the right angle in the other one. That's from Q. So that is Q. Then I move through the side that was stroked once. I pass through that side to angle R. So I'm passing to that side to angle R. So that's QR. Then I pass through the hypotenuse down towards angle P. That's QRP. So I'll say triangle BCA is congruent to triangle QRP. BCA is congruent to QRP. Okay, so that is that about the conditions for congruency. So please, you can watch the videos over and over again. Take notes as much as possible. Then let me give you a simple task. Try to rename the triangles, as in the congruency, the triangles. Okay, try to rename it using the diagrams here. Okay, so you can comment your leave your answers in the comments section. Then also a simple task for everyone as well. This. Okay, so I want everyone that watched this video and actually understand what I've explained, try to state the condition for this pair of triangles, this pair here. So are they congruent? Looking at the diagram, so just state in this blank side here. Okay, you can just write the numbers and then tell me the condition for the congruency. Looking at these two triangles here, so are they congruent? If they are congruent, then state the condition for the congruency. Then look at this one as well. Are they congruent? If they are congruent, state the condition for the congruency. Okay, so that's that about congruent triangles. And later I can post another video, like a class exercise for those that want to try it, giving you some triangles and you have to state which triangles are congruent or state the condition why these triangles are congruent. So have a nice day, everyone. Love you all. Thank you. And also, once again, welcome to AR7 Planets, where it rains mathematical scopes. Have a nice day.